I'm going to explain about amplitude shift keying. So this is the digital modulation technique. So first you should know that what are the different types of modulations, that is analog modulation as well as digital modulations. So in analog modulations, different techniques are there, that is amplitude modulation, frequency modulation and phase modulation. Coming to the digital modulation techniques, amplitude shift keying, ASK, FSK, frequency shift keying and phase shift keying. So now we are going to discuss about amplitude shift keying, ASK. So if you want to modulate, that is digital signal. So for example, I am assuming this is an digital equivalent. So this is an audio. So of course, so after conversion from, that is physical signal into analog, this is an analog signal x of t. So using sampling and quantization, so they will converted in the form of binary ones and zeros. So that is, I am assuming, just assume that this is the message signal. This is the message 10 10. Just assumption only, it is equivalent for hello, just assumption. So but this is an digital signal, digital in the form of digital. So but we want to transmit for long distance communication again. If you want to transmit again, the modulation is required to transmit long distance. So that is the reason we are going for modulation again. So by using, I am assuming this is m of t message signal, m of t message signal. So I am taking one more carrier signal to modulate this signal. So this carrier is again analog. So this is the carrier signal, because I am going for modulating the message signal. So that is the reason I am going for, that is modulated signal, carrier signal. So by using this carrier, we are modulating both the signals. This is the message signal. So message signal is modulating with carrier. So after modulation, you will get the modulated output, ASK output, amplitude shift keying. So for binary, the carrier amplitude is varied according to the message signal. That is the definition for amplitude shift keying. Carrier amplitude is varied according to the message signal. So for example, binary 1, it is having some amplitude. So this is for binary 1. Again for binary 0, so it is having 0 amplitude. Again binary 1 is there, so that is the reason again this is the amplitude. Again for binary 0, it is 0 amplitude. Again for binary 1, it is having some amplitude. So like this it will vary. So this is the modulated signal, ASK signal, amplitude shift keying output. The amplitude is shifting according to the message binary input signal. For binary 1, it is having one output amplitude, and for binary 0, it is having one more voltage. Just it is shifting. So that's why it is named as, that is amplitude shift keying. And some of the students, we can say this digital modulation technique, output is a analog signal. It is not digital. So we need to go for long distance communication. That is the reason we are going for modulation. So here you can observe this, the same thing. So this is an carrier signal and this is an digital message signal. So after modulation, you can see this, for binary 1, it is having some amplitude. For binary 0, it is having 0 amplitude. Again for binary 1, it is having some amplitude. For binary 0, it is having 0 amplitude. So that is an amplitude shift keying. So you can see this, observe this. This is the carrier signal here, carrier signal, and all communications ASK technique is used to transmit the signals, students. So here you can see this is an carrier signal, and this is an that is binary sequence or message signal, binary ones and zeros. So both the signals are modulating and transmitting. After this, you will get the our required output. So for binary one, it is having some output. It is having output voltage, and for binary zero, it is having zero. So means it is shifting again 0 and 1. Like this, it is the ASK output, amplitude shift keying output. Of course, if you want demodulate, again one more carrier is required. So from that we will get the that is demodulated output. Again we are going for carrier. So again carrier we are going, that is carrier. Again both are demodulating. So after that you will get the required signal. So for that they are using that is decision device. So after integration of the that is demodulated signal, so based on the threshold voltage, we can decide either binary 1 or else 0. Some threshold level they will decide. So if it is exceeded that, we can get the output assumed as 1. If it is less than the threshold voltage, they can assume that it is a 0. Again, if it is 1, exceeded 1, if it is less than threshold voltage, it is 0. Like that we can get the our required demodulated signal. This is the ASK output. Again we are going for carrier, both are demodulating. So based on the decision device we can get the our required output, that is original signal. So coming to the application, you can see this everywhere. It requires for long distance communication, either in used in optical communication, transmission, wireless communication, either mobile communication or else everywhere. That is RFIDs, remote controls, everywhere it required to transmit, that is ASK signals. So, and you can see this audio as well as video signal transmissions and radio signal transmission. So everywhere it requires, that is ASK. Thank you. If you have any doubts, you can send me.